Hello guys, and welcome to TKG Games. In this video, we're just going to be looking at an update to one of the Project Euler questions that I posted earlier this week. And the reason why I'm actually coming back to this question was because I told you guys that that was not the most optimal question and that I was working on a second solution. Well, while working on a second solution, I actually found a way to optimize this problem, and it's just one thing. It's not a big deal. Remember what we did was that we decided that if we start with the base case, we could ignore the numbers from 1 to 10, right, for Project Euler question number 5, which would be this one right here, smallest multiple. And we could just short circuit the rest of them, and if any of them failed, we could just skip to the next thing. Well, we were incrementing by 1, so whatever we came up with, whatever the number was, we had to go through a huge gap, right? However, when I was writing my second one, and I realized that we could just take part of, if we take the LCM of 20, 10 is one of them, so we can actually increment. We can increment by that, right? So we can increment by x here, which is 2,520, instead of doing it by 1, and that would actually increase our answer. So what I've gone ahead and done is, like with all the problems that I always do, I always run a test to see how fast it runs. And so what I do is I take the start time in milliseconds, and then I subtract that, divided by 1,000 to get it back in seconds. So something that we can clearly measure against, I guess. So what I'm going to do here is I'm just going to go ahead and run this to show you guys what that time complexity was. So remember, I told you guys that it wasn't like a bad time complexity, but it wasn't like the best time complexity, because in seconds we get 0.309, which is pretty good. It's not up to a second. In fact, it's not even up to half of a second, which is pretty good. However, it's still not the best. So let's go ahead here and actually, so you guys can see the answer is this part right here. Let's go ahead here and actually change this. We're going to say plus equal to, all right, put a little gap here like it wants neat, and then we're going to do 520, and this is it. So when I wrote my other solution, I did it on my laptop, so I don't really have it on this computer to show you guys, but I had 3 methods in there. The runtime came down to roughly about 0.005 seconds, which is close to this one. I guess probably a little bit more computation on that other one. So let's go ahead here and run this, and as you guys can see, the runtime came down to 0.003. Okay, that's a huge improvement. That's multiples of improvement from what we had earlier. And sometimes I'll always revisit these questions again. If I go ahead and I rewrite the solution in such a way that it's more optimal, I will come back here and show you guys what I did to get that optimal solution. But like I said, the only reason why this worked was because 10 is part of the multiple of 20, so we can use the values for 10 with 20, and this would pretty much break down that time in a very large scale. Alright guys, I hope you guys enjoyed this video. I will post this online, and I may also post my other solution on GitHub as well, and yeah, I'm definitely going to post this on GitHub. I just want to, when I reach problem number 10, I'm going to go ahead and create a project or a file that I can just give all of the project files in there for each Euler project, so that you guys can download it. Alright guys, this will be it for this tutorial. I will see you guys in the next. Have a good night. Bye bye.